Thank you everyone for attending this October 2019 GL Communications webinar. I hope that you'll find it very informative and insightful. Uh, my name is Vikram, and I am joined in this webinar by my colleague Prasad Maya, and I'm also joined by Sanjeev Kulkarni. So let's go ahead and begin. The title of this presentation is Comprehensive Ethernet Testing Solutions. And so we'll begin with a really brief overview of GL Communications, just in case you're not familiar with us. We are headquartered in Gaithersburg, Maryland, in the United States. We also have branches in India, Bangalore, India, and Shanghai, China. In fact, Prasad is over there in Bangalore, India right now. And we also have sales representatives located all around the world. So we have a presence globally, and hopefully we're easy to connect to and reach out to no matter where you are in the world. GL Communications was founded in 1986, so we've been around for more than 30 years. And we focus on telecom testing and measurement solutions. So we make hardware and software equipment for test and measurement purposes. And basically any telecommunications network, whether you're on a cellular network, whether you're on a traditional landline TDM network, whether you're on an internet protocol network, whatever network you're on, we have many diverse products that can help test these different networks. We offer capturability, analysis, emulation. We have good visualization options, storage, portability. We'll talk a lot about this later on in the presentation. I just want to briefly mention we also have a consulting side to our company, and so we also do telecommunications consulting. So we've been around for a long time, and basically whatever your telecommunications needs are, you can definitely reach out to us, and I'm sure we have the expertise to help you. Here's the agenda for today. Like I said, we're focused on Ethernet and IP testing. So I'll first give like a really brief one-slide summary of Ethernet. And then I'll talk about network impairments. So basically what can go wrong in an Ethernet network or any IP network. After setting the stage with that, we'll talk about Ethernet and IP testing and why you should care. Why is this an important subject that you should be cognizant about? We'll discuss various Ethernet and IP testing considerations, like what, when, and how to test. And then after that, we'll introduce our product, PacketExpert, which is a very popular product that we sell. And we believe it is a comprehensive Ethernet and IP testing solution. We'll end with a simple real-world example where we show you kind of our own, the way we use PacketExpert to test our own VPN connection. So that's the agenda for today. Like I said, feel free to ask questions at any time. And so let's get started. Okay, so Ethernet technology is basically ubiquitous these days. Not just your local area network, but also metropolitan area networks are running some sort of Ethernet variant. And basically everything except the backbone is running Ethernet these days. So why is that? There's a lot of different reasons. Ethernet is pretty simple. It's scalable. It's fast. So, you have gigabit Ethernet out these days. You have 10 gigabits and, even faster speeds than that these days. So Ethernet is very fast. Ethernet is also very reliable, right? So, if you're on a switched network, you have small collision domains and you have collision detection mechanisms and so on. So Ethernet is very reliable technology. It's everywhere, and we all need to know about it and understand its its advantages and also some of the things you can expect to see on an Ethernet network. Okay, so I'm pretty sure everybody is familiar with Ethernet networks, but it's always important to understand what can go wrong in an Ethernet network or an IP network. What are the types of problems that you're likely to see? So in the left red box here, we see some examples that I just kind of threw up there. No matter what the network is, you can always be subject to faulty equipment. You can also have overloaded equipment. You know, if you have a lot of congestion on the network and your equipment can't handle it all, you can have overloaded equipment. There's all sorts of interference phenomena, electromagnetic interference that can cause all sorts of different effects. On any network, you're always subject to unexpected events like power outages and so on. In a lot of networks these days, you see a lot of rerouting of traffic. So maybe you have some proxies set up, or maybe you have some VPN connections. And so what you're going to find is a lot of rerouting of network traffic, which can introduce all sorts of problems. And then that last one is very important. Sometimes we forget about it, but it's actually one of the most important topics these days, and that's the idea of cyber attacks. So, you know, you always have adversaries out there, and they're always looking to do destructive things, whether it's take down routers, switches, deny service to a web server, and so on. And so you know those other examples I listed above, those are kind of unintentional consequences, but you also have always real world adversaries who are intentionally trying to hurt your operations. Okay, so all of that stuff, what does it all lead to? Well, it can lead to frame loss, frame errors. On an Ethernet network, you know, everything is frames. And so all these type of different things can cause frame loss, frame errors. It can cause out of order frames, duplicate frames. Latency is a big one, obviously. Jitter, which is basically variable delay, and congestion. So those in that top right red box there, those are kind of some of the statistics that you can observe when you're doing any sort of Ethernet or IP test. Now we want to move up a level, and you may be wondering, okay, well, what is frame loss, out of order frames, duplicate frames, all this type of stuff? What does it actually mean? What does it lead to? Well, in that bottom right box there, you see that all of those stuff can lead to a direct loss of mission critical capabilities or some sort of loss of business functions. So we're here to tell you today that all of these statistics here that you see have very, very observable consequences. They have real world consequences, and they matter quite a bit. And it's really the job of any network engineer to be cognizant of these types of statistics and how they can affect your company or your agency or your organization's business functions and mission critical capabilities. So let's kind of think about and brainstorm what type of applications can be affected by those type of network impairments that we saw on the previous slide. Well, both UDP and TCP applications can be affected. So what are your most common UDP applications? It's usually things like voice over IP, video conferencing, or some sort of real-time video stream like closed circuit television. These type of applications are definitely going to be very sensitive to things like latency and out of order frames and so on. Can definitely affect your call quality or your video quality. So those applications are very sensitive to the types of statistics I described on the previous page. Also, it's important to notice that TCP applications are also affected. You may think, okay, TCP has, you know, error detection and error correction capabilities. It can retransmit packets if a packet gets lost. Sure, absolutely. But when you're dealing with real-time data streams, whether it's some sort of geospatial data coming from sensors and satellites, or whether it's financial data like real-time stock prices, or some sort of web activity where you're doing something in real time. These type of real-time data streams will also be affected by latency and frame loss and packet loss and so on. These days, a lot of applications rely on real-time data streams. So just because it's TCP does not mean it's immune to those type of effects I talked about on the previous slide. Also, we know that TCP is used for file transfers and sharing. Like I said before, it's still affected by those types of errors and impairments. And video services like YouTube and so on, where it's a preloaded video, it's usually running over TCP, but again, it can be subject to impairments. So these are kind of like a high-level UDP and TCP applications that can be affected on an Ethernet or IP network. Okay, so the main subject of today's webinar is Ethernet and IP testing. Hopefully the previous slides have convinced you that bad things can happen on a network. So we want to think about how to test these networks. All right, so Ethernet and IP testing, that's a pretty large scope. Every customer we deal with has different requirements in terms of what they want to test. Do you just want to test some layer 1 device like a cable? Maybe you just want to test point A to point B. Is this cable performing the way it is? Maybe you've laid some new fiber and you want to know if the fiber from point A to point B is functioning the way it should be. Maybe you need to test a layer 2 or layer 3 device like a switch or a router or a gateway or VLAN. Maybe you're trying to test like an end-to-end virtual private network. Or maybe you're trying to test, some client to server or client to client connection. So there's so many different things that you could be testing. And so every test case is different. You also need to know when you want to test and what frequency you want to test at. So there may be a certain time of day when you want to test. Or maybe you want to test at multiple times during the day or multiple times during the week or the month. Maybe you want to test under like a high or low stress load. And maybe you're trying to test whether an application functions correctly under high capacity, under a high load environment. Maybe you want to test after there's some sort of infrastructure change. Maybe you've laid new infrastructure into your network, and so now you want to test again. Or maybe there's some sort of circuit handover between the service provider and the customer. The last two, acceptance testing and benchmark testing, that really applies to equipment manufacturers. And maybe when you're producing equipment and you claim that your equipment is gigabit speed or 10 gigabit speed, you need a systematic way to test. So there's different phases in terms of when you want to test. And finally, how to test. There's so many different ways to run Ethernet tests. So you can look at just raw bit streams and look at bit errors. You can look at frame loss. You can look at throughput for different frame sizes. You can look at latency. You can kind of move up the protocol stack, so you can look at UDP packets, TCP throughput, and so on. So there's a bunch of different ways on how to test. And furthermore, you can test at all sorts of different parameters. Maybe you want to test at 10 megabits per second. Maybe you want to test at 10 gigabits per second. Maybe you're only interested in certain frame sizes. For instance, RTP, voice over IP uses RTP packets that which actually transfer the voice, and those RTP packets are 214 bytes. So maybe you're most interested in that type of traffic, so maybe you're only interested in frame sizes of 214 bytes. That's just one example. Maybe you're interested in all frame sizes and all different packet types. So this slide is actually quite overwhelming if you think about it. There's so many different variables to think about when it comes to Ethernet and IP testing. So let's look at some real-world examples. We have a lot of different existing customers, and they wish to do different things when it comes to Ethernet and IP testing. The first one, SLA verification. So SLA stands for Service Level Agreement. And so when a service provider gives you some sort of, dedicated connection, maybe between a branch A and branch B of a company, they will give you certain guarantees on performance, maybe certain committed information rates, or maybe availability. So the service provider, they themselves want to make sure that what they're guaranteeing is actually being met. Also, the customer wants to verify that these service level agreements are being honored. So service level agreements are a big thing that we've dealt with in the past. Equipment manufacturers, like I said before, if whether you're designing a new switch or whatever it is, um, you need to be able to test, whether it's in the development phase, whether you're doing some sort of regression testing, which is like long-term periodic testing, or maybe you're at a production phase and you just want to validate that the equipment is ready to be shipped out. We've dealt with a lot of equipment manufacturers who are testing at these various phases. Finally, we've had, well, another example is delay measurements. So depending on certain customers, they need to know precisely what is the delay from point A to point Z in their network. They need to know precisely what is the delay in a packet traversing that network. And we also have, customers who are trying to, set up a lab environment, and so they need some sort of emulation capability. They need us to be able to generate traffic. Hey, we need to generate traffic at 1 gigabit per second, or we need to emulate a certain impairment, a certain packet loss. Maybe we need to emulate 10% packet loss. And so emulation is a big thing, and we have that capability as well. And so here are just some real world examples of different customer needs. Okay, so finally, we need to think about, if you're going to do Ethernet IP testing, what type of test device do you need? So what I've listed here are some bullets to be cognizant of when you're looking for a good Ethernet testing platform. First off, you want something that's flexible. You want it to be able to support different interface and bandwidths. So whether it's 10 megabits per second or 10 gigabits per second, you want flexibility in terms of that speed. Also, you may want a portable option, or you may want a stationary option. If you're trying to go out into the field, you probably need some sort of portable Ethernet tester that you can take out into the field, move around, test different parts of your network, plug in, take it back out, and so on. Or maybe you just need something that you're going to stick in a rack and you're never going to move it. You just want it in a rack and you're just going to keep it there and just for its lifetime. So you need to consider whether you need a portable option or a stationary option. The third bullet, you want to be able to cover many different types of tests. Like I said, there's so many different types of tests. Bit error rates, you have RFC 2544, RFC 6349, ITU 1564. I mean, there's just so many different tests out there. And you want to be able to, you probably also want to be able to capture packets. You want to be able to filter packets. You may want to be able to play back packets at a later time. You may want to be able to generate your own streams of packets. And maybe you want to simulate impairments. So you want a test device that can cover all of that. Furthermore, you want something that has automation capability. It would be pretty bad if you had to wake up in the middle of the night every night to run a test manually, because maybe every night at midnight you want to run a test, but you don't want to have to manually wake up and do that. You want to be able to write scripts, simple scripts, and be able to run them whenever you want and at whatever frequency you want with whatever parameters you want. And so automation is definitely a very convenient factor that you need to consider whenever you buy any test device. Of course, the last two bullets are true of any sort of hardware or software product. You want a comfortable graphical user interface, and you want a solution that's cost effective. So these are basically the type of things that you want to consider when you buy an Ethernet testing device. Okay, so GL Communications, we feel that we have a an outstanding Ethernet IP testing device. It's one of our most popular products. It's called PacketExpert. It has we have different options on PacketExpert, many different variations. What we're showing you here is the PacketExpert 10GX. And we're showing you both the front and the back of the device there. Everything I just mentioned on the previous page, we believe that the PacketExpert checks the box. So we believe it's flexible. We have both portable and stationary versions. PacketExpert can do all of the tests that I just mentioned on the previous slide. It has automation capability, it has a comfortable GUI, and it's a cost-effective solution. And in the next several slides, we're going to show you specifically each of these bullets and why we believe PacketExpert checks the box on each of these. At this point in the slide deck, I'm actually going to hand it over to Prasad, and Prasad will kind of walk you through each of the features of PacketExpert. And so Prasad, feel free to unmute your mic and take it away. I will jump in later in the slide deck when we show an example of a real-world VPN using our PacketExpert product. But for now, Prasad, feel free to start.
Okay, thank you, Vikram, for the introduction. So, as Vikram mentioned, we'll just go in detail looking at this PacketExpert product. In this slide, we just show you how this platform, the PacketExpert platform, is a flexible platform, mainly because the single platform supports multiple speeds. This is one of a big requirement because people use, say, 10, 100, 1000 Mbps speeds, that is the 1 gig, the gigabit Ethernet interfaces. But slowly, people have been switching over to the intermediate speeds like the 2.5 Gbps, because the 2.5G speed fits into the existing gigabit infrastructure without any major overhauling. 2.5G is picking up nowadays, and also 10 Gbps speeds is also being deployed, and so people are looking for option to a single option to test all these speeds. So as they upgrade their infrastructure, they can use the same already existing test equipment to test their different requirements. So if you see this, so we have the single device supports 4 ports. So out of which the 2 ports, they support both SFP and RJ45 interfaces. So and the other 2 ports, they support the SFP interfaces. So all these 4 ports, they are capable of supporting 10, 100, 1000 Mbps speeds. So the first 2 ports, it can be either through an SFP, it supports optical interface, or a RJ45 interface. And the last 2 ports, they are SFP based ports. So if you plug in a copper SFP, 1G SFP, so you can have all the 4 1 gigabit ports. And the port 3 and 4, they also support 2.5 Gbps electrical interfaces. So you just plug in an appropriate copper SFP, and they just convert into 2.5 gig. Similarly, these 2 ports, the port 3 and 4, also supports 10 gigabit through the use of an appropriate SFP. So this single platform supports either 4 1 gig ports or 2.5 gigabit ports or 10 gigabit ports. So another aspect of our this PacketExpert product is, as Vikram mentioned, there are multiple form factors available depending on the testing requirement at the place of use. You can choose between different form factors. So we have this portable unit, which is a compact unit, very lightweight, and you can carry it to the fields, which works in conjunction with the laptop. So you connect the laptop to the hardware through a USB 3 port, and the software runs on the laptop and controls the hardware. So this can be carried to the field, to different locations, and be used as a portable unit. We also have a rack unit. The one we have both 1U and 2U racks. So multiple such units can be stacked here to increase the density. So 1U unit can have 3 such devices, giving a total of 12 ports, and 2U rack options will give a total 24 ports. And this has a built-in CPU in this. Okay, so this rack option has a built-in CPU, so there is no need for any extra PC to run. It's a comprehensive unit. So this, as Vikram had mentioned before, not only is it flexible in terms of the port speeds in the same platform, we have different modules which are supported by the same platform. For example, we have wire speed BERT, RFC 2544, and multi-stream UDP traffic generator, and RFC 6349, which is the multi-stream TCP throughput test, and ITUT Y.1564, which is the Ethernet SAM, that is service activation methodology test. So used to test the Ethernet service activation. So these are like active modules where the traffic is actively generated and analyzed. And we also have some passive modules, like this impairment simulation, where the same platform, by loading a different module, is converted into a passive module where the traffic flows through 2 ports. So it acts as a transparent bidirectional link, and traffic goes in one port and comes out the other. In between, the various impairments, like the bandwidth simulation or packet loss, they are introduced. And we have wire speed packet capture and playback also. Which again is a passive module where traffic is transparently passed through the ports, as well as filtered and captured. We'll go through each of them in a little bit later. So now let's see how PacketExpert can be used in actual testing. What are the different ways and different configurations in which it can be used? If you take a simple example, so it can be used to test, say, a local switch or Ethernet network. Like you can perform layer 2 testing here, where you can just assign MAC addresses to the ports and say run a BERT test from one end to the other end-to-end BERT test. Or also you can run one side BERT and other side Loopback, where the PacketExpert can also act as a Loopback device. So it will swap the MAC addresses and IP addresses and send back the traffic. So you can do the measurements on one side, or you can do end-to-end test and do measurements on both sides. So this test can be started and stopped anytime, at either end or at the local end if it's a loopback test. Okay, so one more scenario is you can use PacketExpert to test between different IP networks. For example, here we are using it to test between two different subnets, which passes through switches and routers, and again you can do end-to-end test, or you can do uh, test with a remote loopback. So you can assign IP addresses to each of these ports, and PacketExpert user can define the entire various fields in the headers, including the IP address and the UDP ports, and PacketExpert generates the traffic accordingly. Yeah, so it can be used, say, for example, as Vikram was talking about, if you, so they say you want to test a cable, just a cable, so you can just use connect a cable between port 1 and port 2 and do the test. Or if you want to test a local switch or a router, so you can just connect the switch to the different ports of the PacketExpert and just conduct the test here. So this is most useful in lab environments, or say in say manufacturing testing. So when you want to test the network equipment, even in those cases, PacketExpert is quite useful in this configuration. So one more very useful scenario in which some of our customers are using PacketExpert is, say nowadays we have many switches with multiple one gigabit ports and a single or one or two 10 gigabit ports, where 10 gigabit ports can act as a uplink, and it carries the traffic from different 1G ports and sends it out, or receives uh, um high traffic on its high capacity ports like the 10G ports, and distributes it among the 1G ports. So to test such scenarios, we can make use of PacketExpert and its flexibility. So this is an example of that. So here there is a switch, which is the DUT. It has a 10G port and 10 1G ports. And suppose you want to test this, then you can use on one side, you can use a 10G port of PacketExpert to send multi-stream traffic using the multi-stream traffic generator towards the 10G port with appropriate configuration for each stream, so that it goes out of each 1 gig stream. The incoming 10 gig stream is distributed by the DOT into 10 1 gig streams, and you can receive each of the streams using the rack mount high density unit. Here this is 12 port unit, so you can use 10 ports to receive the streams, and this will act the right hand side. The rack unit will act as a loopback, and every port will do a loopback, and it will send it back, which will again come back to the 10 gig port, and come out of that, come back to the left hand side PacketExpert 10 gig port, where it gets analyzed, and the various measurements like throughput, packet loss, jitter, delay, uh, all those things are measured and reported on the left hand side PacketExpert. So this is a very useful scenario, mainly used for again equipment testing. Okay, so again we PacketExpert has this Y.1564 based so Ethernet SAM testing, that is a service activation method testing. So you can use on one side, again this is similar to the previous scenario. So this is more like network testing. So you can direct the traffic, the multi-stream traffic, towards the say the Ethernet network, which say a service provider network, which supports multiple Ethernet services, and you want to test that. So you can put the multi-stream generator on one side and a loopback device on the other side. So, and you can define each stream to emulate different kinds of traffic. Say, for example, voice traffic has certain characteristics like the RTP, which has a payload length of say 214 bytes and an IFG of 20 milliseconds. So you can specify each stream to have a separate frame size and a rate, and you can define multiple streams like that, and so that the frame size, rate, and the protocol like the UDP, IP UDP, with these will emulate a voice over IP traffic. Similarly, you can have a different frame size and rate to say emulate normal data traffic. So you can define multiple streams and send them through the network and have it loop back on the other end. And when it comes back again, we do analysis for throughput, latency, jitter, frame loss. And we have two modules here. One is strictly based on Y.1564, which does the service activation test, that is service by service, as well as service performance test. Do the test all the services at once. And we have a more simpler multi-stream generator, which is similar to Y.1564, but does not. It's a simple multi-stream generator. So the advantage of PacketExpert is, since it is hardware based, everything is done everything is possible at wire speed. So you can generate full 10 gigabit wire speed traffic and analyze it. And one more. So now we come to we have seen how PacketExpert acts as an active endpoint, generating active traffic. Now we have another mode where it acts as a network tap. So here it acts as a passive device. So we connect it transparently between two routers or two traffic sources, and we pass it through the ports that they are called the tap ports. So they pass transparently through the two ports, and either router will not notice any difference there. But what we do is we apply to the passing through traffic. User can define filters. We have a very highly flexible filters, and we can capture those packets, filtered packets, and send it out over the other two ports. So so this way, when the packets coming out of the output ports can be fed to a say PC, and maybe you can use a packet analyzer like Wireshark or GL's packet scan to analyze in real time. So only the traffic of interest can be filtered and captured and analyzed in real time. And in this mode, we have one more powerful feature, which is the TTL output. So user can map the filtered packet to a TTL from either direction, and once that condition occurs, when the packet is captured, a 5 volts TTL signal is sent out, and user can map up to 12 filters to the 12. We have capacity up to 12 TTL signals. So user can use this to map each filter to one of the TTLs, and as shown is here, he can use it for his own purpose. For example, seeing in an oscilloscope. Okay. So the previous the tab configuration and the TTL, some customers have used it for, as Vikram mentioned, the precision delay measurement. As packet traverses through the network, so we can trigger events at multiple points, and we can even get the packets to a center location and analyze the time difference between them. So it has been very useful in that scenario. Okay, so one more important, somewhat completely different application or the module within PacketExpert is this impairment simulator. So again, this works similar to the previous one in that the traffic passes transparently through two traffic sources. For example, it could be between two LANs. So, and user can apply user can segregate the traffic into multiple streams, and for each stream he can apply impairments. So these impairments are typically found in say WAN networks, so say WAN links in long haul networks. And so this is like simulating a WAN in the lab. So so the very convenient way of testing your applications, like how they will behave in the WAN. So you can introduce impairments like bandwidth throttling to emulate say a T1 line, for example. So you can limit it to 1.544 Mbps, and introduce latency and jitter. So either constant latency or variable latency, and packet loss. You can define say 1% packet loss, and packet effects like reordering and duplication. And you can even introduce logic error insertion. So you can define the offset within the packet and introduce errors there. Yeah, so this obviously has a graphical user interface and a very easy to use graphical interface. So you can all the features and functions are available through the very easy to use GUI in this. So whatever applications or modules we have been talking about, all the features available in the through the GUI. The GUI is for, as Vikram mentioned, is for the normal operation where the user will be in front of the PC and we'll do test. We'll be there when the test happens and it is done, and he can read the results. But we also have we provide APIs for automation, so which is useful. We have found that it is useful for many customers. So we provide C#, Python, and TCL. So all these follow a client-server model, and we use our own proprietary maps automation platform for that. But so on top of that, we have various client libraries. We provide client libraries, and simple. We also provide simple APIs on top of the client libraries. So using these APIs, user can develop their own applications. Say, for example, if you want to do a bird test, and you can use C# or Python APIs and develop sample applications and do complete automation. So we even have customers who have used this C# to automate it with LabVIEW. Okay, so yeah, as I mentioned, user can develop their own sample applications using C# and Python. These are some of the examples. We also provide some sample applications so that user can come up to speed by following the examples. So those are available with the product. And these are quite easy and simple to use applications. Okay, so this was a view into the product, and now Vikram will explain how we actually use the test, the PacketExpert, to conduct a test between GL India and GL USA to test our VPN network. So Vikram, you can take over now.
Thank you, Prasad. So we just wanted to end on an example. And here at GL Communications, we have a VPN connection between our Maryland, USA office and our Bangalore, India office. And this VPN is basically essential to us. We can easily pick up the phone, dial an extension, and call each other. We can share files and so on. We're in constant communication with our India office. And so if our VPN goes down, that makes life pretty inconvenient for us. So we have a VPN connection set up, but as you know, in reality, the packet is passing through multiple routers. It's getting encrypted, it's getting decrypted, it's going through undersea fiber optic cables and so on to reach its destination in India. So you can basically guarantee that there's going to be packet loss along the way. There's going to be all sorts of effects, latency, and so on. And so let's just quickly just kind of show you how we use PacketExpert to test this VPN connection. Um, we're going to run a simple bit error rate test. So we're just going to send Ethernet frames between the two endpoints. We gave it a fixed frame size, 1514 bytes, which I think is around the maximum frame size for Ethernet. We're going to run the test for 24 hours. One feature I forgot to mention earlier on is you can basically run this PacketExpert indefinitely. You can have it test for as long as you want. It's not going to overheat. It has a built-in fan. So we ran this test for about 24 hours, and we had no problems at all. In this specific VPN test, we're going to send UDP packets. We just give it a source and destination port. And really, those bottom two bullets are what we're interested in. We want to know what is our throughput on this VPN connection, and what is our bit error rate. Okay, so the results were pretty interesting. What you see in blue, that blue line there, is basically our throughput. We ran this test at 1 megabit per second only because we didn't, it's a live network and we have other users on our network and we didn't want to hog all the bandwidth. So we just ran the test at 1 megabit per second. And you see over the 24-hour time period, you see that we have these like drops in throughput every now and then. And basically what that means is that we're kind of intermittently losing the VPN connection just for a few seconds, and then it comes back up again. So this is like kind of like a real world what a VPN will perform like. You can't expect a purely continuous, perfect connection. And so that's what we see here. And the other thing I want to point your attention to is all these red dots, especially the cluster of red dots. I don't know if you can see my mouse, but the cluster of red dots early in the test. And what you actually see is that during our USA peak hours, when we're running this BERT test from here to India, we actually see a lot of bit errors. And so the y-axis on the right-hand side is an exponent. So we see, anywhere between 100, 10 to the 2, and 10 to the 3 bit errors at any given second. So that's kind of interesting. We see a lot of bit errors only during our peak work period. Once you pass out of that peak work period into the evening time and into the nighttime, you see that there's a lot less frequency of bit errors. And then the next morning comes again, and we see more bit errors as the workday starts up. So this is kind of like what you would expect from a real-world VPN. You're going to see bit errors, especially when you have lots of traffic on your network, other users are on the network, and you will see intermittent drops in the connection. The PacketExpert can give you real-time statistics like that as a function of time, and it can also aggregate all the statistics over the whole testing period. So what it will do is it can export the results as a CSV or a PDF or whatever you want. And I just took a little screenshot, a little snippet of some of the statistics that it produces. So you see here over the test, we sent like about 10 to the 10th bits, and we had about 80,000 bit errors in those 10 to the 10th bits. We see that we had a little bit of sync loss where the bit error, where the bit streams were out of sync. That happened about 2% of the time. And usually those out of sequence seconds, what that means is that packets are being dropped, and so the expected packet is not received, and the next packet is received, so there are some out of sequence packets there as well. So the out of sequence packets indicate packet loss. So these are just some cumulative statistics that the bit error rate test produces. There's actually a lot more statistics, but we didn't want to overwhelm you in this presentation, so we're just kind of showing you the basics of a bit error rate test. You can also do RFC 2544 tests. So here we're just showing a latency test. as a function of frame size. So if you look at these red bars here, basically all you need to know is that no matter what the frame size was, the Ethernet frame size, we were getting roughly a constant latency. Latency here is defined as the round trip time. So you send a packet and you receive the acknowledgement, and so the round trip time uh, is roughly around 220 milliseconds, regardless of the frame size. And that's what you would expect for a good functioning network. It should not be, unless you have some sort of quality of service enforcement, it should not be, parameters should not vary as a function of frame size, or at least the latency should not. So that's just one example. That's just another example of what you can test on a VPN connection. So I don't want to bore you with too many stats or graphs or anything. Hopefully that presentation was clear to you, and we really thank you for attending this presentation. It'll be made available on our website, and please, if you have any questions about PacketExpert, you can ask them now, or if you prefer, you can email us at info@gl.com. If you want a quote, we can send you a quote, or if you just need more information, feel free to reach out. And so with that, thank you, Prasad. Thank you, Sanjeev. We'll stop here and we'll take questions if anybody has some questions. So, Prasad, do we have any questions right now?
Uh, yeah, we don't have any question, but we need to answer. I mean, I feel that what is the status of releasing the higher speed models in the future? Like, are we working on any higher speed or bandwidth? Availability
Yeah,
in PacketExpert.
yeah. Prasad, do you want to talk to that?
Yeah. Yes, definitely. Right now, we have from 10 to 10 Mbps to 10 Gbps. So we are working on higher speeds like 40 gig and 100 gig. And we are actively working on that, and it will be available in the near future. So it'll be similar to PacketExpert platform, but with 40 and 100 gig capabilities.
Okay, and how about the support for IPv6?
Yes, we do have complete support for IPv6. Yes.
We have one small question here.
Sure.
Uh, they're asking, they want to ask about how do you price the C hash, Python, and TCL support?
Okay. How
The
do you
pricing,
price
pricing,
pricing?
yeah, yes.
Okay, so the pricing is we have a price for the basic unit, the hardware, and we have the license for this. All the clients we have a single license. So if you buy that optional license, then you'll be getting all the clients, C sharp, the Python, and TCL.
And we have another question. Do we have any better standard than RFC 2544?
Yeah. So we have so RFC 6349 is TCP throughput testing. So that's specific to TCP. Whereas RFC 2544 is kind of just looking at the raw frames, Ethernet frames. Uh, so we do support that TCP throughput testing.
Yeah, and we do have the Y.1564 support, which is what it's somewhat better than RFC 2544 in that it continuously does the testing over a longer period of time, and does say all the services or streams together. So which is a more realistic kind of testing.
Yeah,
Yeah.
we
Just
have
to reiterate that, yeah, we can generate multiple streams, and these streams can be defined any which way you want. They can be defined on a frame size. They can be defined on a source port or destination port or source IP, destination IP. So we can do, and then we can run the throughput test or a latency test on each stream individually. So that's a huge advantage over RFC 2544, which I think just says, you do it, you do a test with in this manner, but we can have multiple streams running simultaneously.
In terms of Indian technical requirement, do we assume that RFC 2544 is better one?
I think even in I don't know about Indian technical requirement, but mainly like RFC 2544, it can be used, but it's not like say testing a real world scenario. So if you want to test say a long haul link, say as we told VPN link between here to USA. So RFC 2544, if you run, it will just test say for individual frame sizes for say a shorter duration and report them separately. So that's how the standard is. So it was mainly meant for testing local devices. Whereas this Y.1564, it was designed keeping in mind such kind of testing, where you can send out multiple streams with different rates and different frame sizes, so that a mix of traffic is passing through the network, and maybe even test the priority handling in case there is some QoS implementation in the network, and then see how the network handles everything together. Uh, so I think those are like um two sort of two different testing scenarios, which both can be used. But Y.1564 is like more like testing the real world scenario.
Yeah, thank you, Prasad. One last question we'll take, and they're
Sure.
asking, what are the measurements that you are getting in the loopback side, or it is just a physical loopback and all the measurements occur in the generator side?
Yeah, I'll answer that. Yeah, that's true. The loopback side is not just the physical loopback. It does swap the addresses, but there's no measurements done on the loopback side, and everything is done on the generator side. So both generator and analyzer are running on one side. So all the measurements which we uh, produce here are actually round trip measurements. So even the delay would be round trip delay. So yeah, and one more thing is in the same setup, say for multi-stream generator, we are also working on adding this GPS support. So then it can be true one to end-to-end test, where you can run the same. We can run generator on one side and analyzer on other side. So currently the problem is the time synchronization. So the delay measurements will not be accurate. So once the GPS support comes in, so the time synchronization problem is solved, and we can have one-way delay and all one-way measurements, both upstream and downstream. So we are working on that, and that will also be available in the near future.
Yeah, that's about it. Thank you, Prasad, and thank you, Vikram.
Okay, thank you everyone. Those were fantastic questions, and please reach out to us if you have any more questions or comments, and we'll go ahead and end the webinar now. Thank you.
Thank you.
Thank you, everybody.